Right, so the electrolytic cells involves non-spontaneous redox reactions. So these reactions can only occur if you have a source of energy, electric energy. So the energy conversion is electric energy to chemical energy. That's the energy conversion.
So now,
yes.
basically it's non-spontaneous.
Yes.
And that is the definition of electrolytic cells.
Yeah, it describes an electrolytic cell. Or all these things describes electrolytic cells. The reaction is non-spontaneous and it is endothermic.
Is the other one exothermic?
Yes, gives off. It heats up after a while. When it works, it heats up. So it's exothermic. Now we do get different electrolytes. The electrolytes could be a paste. It could be a liquid, or it could be a solution.
Ma'am, what about a molten?
Liquid is molten, yes. Molten solids, the molten substances. So if you take sodium chloride and you melt it, you'll form an electrolyte. But to melt sodium chloride is more expensive than to dissolve sodium chloride. So let's go to that as an example. Electrolytic cells are usually used to plate objects or to purify metals. We're going to describe the plating process as well as the purification process. Can I move to the next slide or must I wait a bit? Okay. What is the definition of an anode? It's the electrode where oxidation occurs. And the cathode is the electrode where reduction occurs. Now, oxidation is a loss of electrons. No? So, and reduction is a gain of electrons. Now, in the galvanic cells, the place where oxidation occurs gives off electrons, and that electrode is classified as negative. The electrode where reduction takes place takes in those electrons, so that electrode is classified as positive. Here in the electrolytic cells, the loss of electrons occurs at which electrode? Now here the electrode is actually physically connected to a battery. So which electrode will take the electrons given off by the oxidation? Will a negative electrode take negative electrons? No. So this anode will be charged positively by the battery. I'll explain it with a diagram just now. And the cathode in the electrolytic cell must take the electrons. What charge will take, mate? Sorry, man. Will give electrons. What thing will give electrons? Gain of electrons will take place at this one. What electrode will make the chemical take the electrons? It is charged negatively by the battery. Okay. So it's just the opposite to the voltaic cells, the anode and the cathode. And it makes sense because the whole functioning of the electrolytic cell is opposite to that of the battery, the galvanic cell. So let's draw an electrolytic cell. Now this is a simplified drawing. Different electrolytic cells will have different construction. So this is just a simplified drawing. Because sodium chloride cannot be melted in a simple open beaker like this, but I'm going to use sodium chloride as the example. So here we have molten sodium chloride. So it is a liquid, not an aqueous, it's a liquid. So I admit that this is really a simplified diagram. It can't be an open beaker like this because it forms toxic gas, chlorine, and it forms a liquid sodium. Right, so let's look at it. This is the positive terminal, that is the negative terminal. Sodium ions will be present in this solution, and chloride ions will be present in the, not solution, the liquid. Where will the chloride ions be attracted to? They will be attracted to the positive electrode. Where will the sodium ions be attracted to? They will be attracted to the negative. The chlorine here gives its electrons. The electrons will go through the wire to the positive terminal. That's the flow of the electrons. They'll move through the battery, they'll come out the other way, and because the electrons are coming to this terminal, this electrode, they can attract the sodium ions. So here the sodium receives the electrons. So chloride changes into chlorine. Am I right? And two chlorides will change into chlorine molecules, and two electrons will be given off. This process is called reduction. No, man. Oxidation. What is wrong with us on this Friday morning? This is oxidation. So this is the anode. And the cathode is this one, where sodium ions will take up electron to make sodium. So this is my reduction, half reaction. Let's find these on the table of reduction potentials. can you see the reason for this to be an electrolytic cell needing that battery is that sodium is a stronger reducing agent than what? Chloride. Ions. Therefore, sodium sodium ions cannot oxidize the chloride ions to chlorine spontaneously. I could say that the sodium ion is a weaker oxidizing agent than chlorine, and therefore the sodium ions cannot oxidize chloride to chlorine spontaneously. It's a non-spontaneous reaction. So this example is an example where we use the electrolysis of molten sodium chloride.
What's molten?
Melted.
What's melting?
You turn the solid into a liquid. You heat it up until it's melted. Your ice melts in your fruit juice.
Come on.
Yes.
Would they ask why do we have to melt it first?
Yes. Can a solid ionic substance be an electrolyte?
No, I mean because I did an example like this and they had reasonings of crystal lattice and
Yeah, in the sodium plus ions and the chloride negative ions, they stick together in a crystal lattice because of the strong Coulomb forces. So those ions are not free to move. So any salt, if you want to use it in an electrolytic cell, you either have to melt it or you have to dissolve it in water. I'm going to do the example that we're going to look at next is the one where we dissolve the salt in water and then see what happens. So this salt is molten sodium chloride. So you only have sodium and chlorine in the electrolyte. The electrodes that they use is most probably carbon or graphite electrodes. They can't use a chlorine electrode, and they can't use a copper electrode. They can't use anything that will react. And platinum is expensive, so they use it where they have to use it. They either use platinum or graphite as an electrode.
which one is graphite?
Graphite is carbon. Okay. Can I go to the next slide?